Welcome to this tutorial. I'm solving question number 10 of paper 2 October-November exam series of 2019 in this tutorial. And the topic of this question is isotopes and the half-life. Question says all the isotopes of the gas radon are radioactive. So this is one radioactive substance which is found in air and naturally everywhere. State one similarity and one difference between the nuclei of two different isotopes of radon. So similarity is that like all the isotopes, they have same number of protons, and the difference would be they must be having different number of neutrons. The next part says the isotope radon-222 decays by an alpha particle emission to an isotope of polonium. The proton number or the atomic number of polonium is 84. So since radon-222 is decaying by emitting an alpha particle, so the mass number for polonium must be found by subtracting 4 from the mass number of radon, and the mass number for polonium would be 218. Determine the number of neutrons in an atom of polonium isotope. So to find the number of neutrons, we consider the mass number and subtract the number of protons from it, and the answer we get is 134. So the number of neutrons in a polonium isotope would be 134 here. Determine the number of protons in an atom of radon-222. Since the proton number in an alpha particle emission decreases by 2, so it means that if the polonium has the atomic number of 84, the radon must have a proton number 2 greater than this. So the number of protons in the radon would be 86. The next part says describe how a neutral atom of helium differs from an alpha particle. So in a helium atom has 2 electrons, and it is one of the noble gases. In the orbit around the nucleus. So this is the difference between a complete helium atom and an alpha particle. The next part says in an experiment to collect a small quantity of helium, a sample of radon is enclosed in an inner glass tube which has a very thin wall. So this is the glass tube here, this one, and we have radon-222 in it. Outside the glass tube there is vacuum in this area, and this is the container, and a seal is placed over here. Figure 10.1 shows that this tube is placed inside a container that is initially evacuated. Both the container and the inner glass tubes are sealed. As the radon-222 decays, alpha particles pass through the thin wall of the inner glass tube, and they come to this region which is evacuated. Figure 10.2 shows how the total number of alpha particles produced by the radioactive decay of the radon-222 changes as the time passes. So initially there were no number of alpha particles, so their count or on the initial time is 0, and as the days passes, the number of alpha particles produced are increasing in a specific way, which when plotted on the graph we have a curve over here. Now, number of alpha particles are indicated on the y-axis and the time in days is being indicated on the x-axis. Use figure 10.2 to determine the number of alpha particles produced in 7.6 days. So for 7.6, this line is representing 7 and 7.6 would be represented by this box. So I'm drawing a line up till the curve, and the curve is here on the value of 2.1 into 10 raised to 10. So the number of alpha particles after 7.6 days would be 2.1 into 10 raised to 10. Initially, there are 2.8 into 10 raised to 10 atoms of radon 222 in the inner glass tube. As each radon 222 atom decays, it produces an alpha particle. So it means uh, the number of alpha particles are indicating the number of radon 222 atoms which have decayed. Calculate the number of radon atoms that remain after 7.6 days. So for finding the remaining atoms of the radon, we start with the initial value, which is 2.8 into 10 raised to 10, and we subtract the number of radon atoms which have decayed after 7.6 days, and the decayed atoms would be equal to the count of alpha particles which are there after 7.6 days. So by simply subtracting it, we get 0.7 into 10 raised to 10, or if I convert it into the standard form, it would become 7.0 into 10 raised to 9 atoms. So it means that 7.0 into 10 raised to 9 atoms would be remaining after 7.6 days. The next part says using the number of radon atoms present initially and the number present after 7.6 days, calculate the half-life of radon. The atoms remaining after 7.6 days are 7.0 into 10 raised to 9. When we divide this number by the initial count, which was 2.8 into 10 raised to 10, this would give us the answer as 1 upon 4, which means it is 2 raised to 2 or 2 square, and which shows that the number of half-lives which have passed during this time is equal to 2. So 2 half-lives have passed in a time period of 7.6 days. So 1 half-life would be when we divide 7.6 by 2, and the answer is 3.8 days. This would be the half-life of radon. So I'm writing 3.8 days in the answer space. In the next part, it says the alpha particles become helium atoms which are collected in the vacuum shown in the figure 10.1. Explain in terms of properties of alpha particles why the wall of the inner glass tube must be extremely thin. It should be thin because alpha particles have very weak penetration power. So if it is made thicker, alpha particles won't be able to pass through it. So alpha particles have very weak penetration power. That is why the glass tube must be made very thin. In some parts of the world, radon 222 accumulates in the air in buildings and is breathed in by people. Explain why the presence of an alpha emitter in the lungs is particularly hazardous. So it is hazardous uh, because alpha particles have strong ionizing effect, and this ionization can cause cell mutations or cancer in the human body. That is why it is not safe, and it is hazardous to inhale an alpha emitter gas like radon. So the question ends here with this part.
We try to explain complex concepts in simple language and with effective examples. If you liked the video and the way we explain the subject, consider liking this tutorial, commenting on it and subscribing to our channel, and press the bell icon, so that you stay updated and get notified when we upload more videos. Thanks for watching.